So standard air, which is our baseline, and that's what these conditions are, 13.33 cubic feet per pound and 0.075 pounds per cubic foot. They're reciprocals of each other. And when I say reciprocals of each other, if you've never played the reciprocal game, here's what I'm talking about. Specific volume, 13.33 cubic feet per pound, which means that if you take one of those cubic feet, that's a 12 by 12 by 12, it's going to weigh 0.075 pounds. If you take 0.075 pounds times 13.33, you're going to end up with a pound, 1. Okay, so let me exercise that thought. I'm going to go 1 divided by 13.33 equals, boom, 0.0750, and then the decimal places go on and on. When you're dealing with air or anything else that we are taking measurements of in our business, if you go 2 places, at the very most 3 places to the right of the decimal point, you're far enough. So, but here's the reciprocal. Okay, now if I take this number, 0.075, this is a reciprocal of specific volume, which happens to be density. If I take density, which is 1 divided by 0.075 equals, go figure, 13.33. The value is, if you know one value, in other words, if you know the volume, the specific volume is 13.33, you can always, by running the reciprocal, 1 divided by 13.33, you can always find the density. If you know the density, you can always find the specific volume by running the reciprocal. 0.075 divided into 1 is going to be 13.33. What does specific heat mean? The base description of specific heat is the amount of heat required to change the temperature of 1 pound of a substance 1 degree Fahrenheit. In the case of water, as you should have learned in one of the earlier modules in 101, the specific heat of water is 1. So it takes 1 BTU to change 1 pound of water 1 degree Fahrenheit. And that means putting 1 BTU in will raise the temperature 1 degree Fahrenheit. Taking 1 BTU out will lower the temperature of 1 pound of water 1 degree Fahrenheit. So the specific heat of air is 0.24 BTUs per pound, meaning if I have 1 pound of air, which would, in standard air, 13.33 cubic feet, 1 pound, I would add 0.24 BTUs, and I would increase 13.33 cubic feet of air 1 degree Fahrenheit. That's amazing. Air is very easy to heat and cool. It doesn't take much heat to change the temperature. Last thing in here is relative humidity, 30%. Remember, I'm talking about standard air. I'm not talking about any other air. I'm not talking about Arctic air or tropical air or any other kind of air. I'm talking about standard air. If we don't have a baseline, how can we calculate from or to or anywhere else? That's what it's about, standard air. One distinction that I have to make, note that these properties do not define standard atmospheric conditions, but standard conditions. So when we're talking about standard conditions, we're talking about HVAC stuff. We're not talking about the weather, all right? Make sure you make the distinction. Standard atmospheric conditions are a different baseline. 59 degrees is the temperature, the dry bulb temperature of standard atmospheric air. Make the distinction. When we're talking about standard air, it's HVAC information. We use air as our transfer medium. And that's why this is all so important. If you're working on a warm air furnace, if you're working on an air conditioning system, which is blowing air through an evaporator coil that is taking the heat out of the air as it goes through, running air through a heat exchanger on a gas furnace, which is putting heat into the air as it goes through, running air through a dehumidifier, which is condensing the water out of the air as it goes through. All of these things that I'm talking about, and air conditioning in general, remember we are talking about air conditioning, all these things are running through something that is conditioning the air.